in the last class we were discussing about the matrix operation, and in that matrix operation mainly we discussed the transpose of the matrix. The matrix operation, in that what we were discussing, the first one is the transpose of a matrix. As I told you, for the shared memory model it is not a problem at all, but the problem comes when it is a mesh connected machine. We also discussed about the this transpose algorithm for perfect shuffle machine. Agree? And we also mentioned this thing that tree is not a good model for matrix transpose or that type of operation. Now, then we discuss about the matrix multiplication. Shared memory model is not at all a problem. But if it is a mesh connected machine, then we also mentioned that the data is inputted in such a way that it becomes a pipeline one, and efficiently you can do the multiplication operation. Agreed? Up to this we covered. Yes or no? Now, suppose the data is available in the mesh itself, because sometimes I tell that the data is coming from other processor, and sometimes I tell no, data is available based on our how we can solve. Based on that we are designing the thing. It's not a good thing. Now let us the data is available in the mesh itself. Now, for simplicity, let us consider one 4x4 matrix, and then I like to give it to you as a home assignment for n cross n matrix multiplication. So I am assuming there is a 4x4 matrix A, and another one is B, and the model is wraparound mesh. So like this, you have A11, A12, A13, A14, A21, A22, A23, A24, A31, A32, A33, A34, similarly you have B11, you have this two matrices, and each processor contains two elements. One is for A elements and one is from B elements, right? Now you observe that if I have to multiply, these elements are not multipliable. These elements are not multipliable because matrix multiplication you have Cij A, K, B, K, J over K. So the two elements are multipliable if one's column is matched with the column index matched with the row index of the other one. Now, in order to make it multipliable, you observe that if I make the matrix B as a transpose of the matrix, then you will observe that it is multipliable. So transpose of this matrix B, if I perform, what happens? So that I discussed in the last class, how to do the transpose. In that case, you get A11, A12, A13, A14, A21, A22, A31, A41, A42, A43. Now you observe that every element is multipliable. Right? And if I multiply it, this is the product of C11, this gives you the product of C11, C11, C11. This gives you C22, 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 C22. This gives you C33, 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 C44, 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 C44. Right? So at the first multiplication you get the diagonal elements. Perform the additions and move the data into the appropriate positions. Perform the additions of C's and move the data into the appropriate positions, which you need order n time if it is n cross n matrix, right? Because order n time is okay. Because you have to, data movement is required. So whatever procedure you follow, order n time you have to give. So one way is that you would bring one by one and add it and move the data into the approach. So order n is sufficient if it is n cross n matrix. So diagonal element you have fixed, right? Then you do the operation rotate up A. So we told you what is rotate up A operation, because in the wraparound A elements would be rotate up. So you get A21, A31, A41, A11. You get B11, B12, B13, B14. Then you get here A22, A32, A42, A12, A13, A14, and A43, A44, A33, A34, A23, A24. B21, B22, B23, B24, B31, B32, B33, B34, B41, B42, B43, B44. Now again you observe that you get the situation of multipliability, and you get here C21, 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 C3, C32, 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 C43, 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 then A14, sorry, C14, 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 right? So you can again do the addition of the C elements and you can move the data into the appropriate positions in order and time. So next step, again you rotate up A. You get A31, A41, A11, A21, A32, A42, A12, and A22, A23, A24, A13, A14, A43, A44, A33, A34, and here it is B11, B12, B13, B14, B21, B22, B23, B24, B31, B32, B33, B34, B41, B42, B43, B44, and you observe that they are multipliable, and you get C31, 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 C42, C43, C42, 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 A13, sorry, C13, 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 C24, 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 C24. So you add them and place it to the appropriate place in order and time. Again you do the rotate up. A41, A11, A1, A42, A12, A13, A14, A22, A23, A24, A32, A33, A34, A43, A44. So this gives you the guarantee of C41, 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 C12, 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 C23, 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 C34, 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 and you add them and place it in the appropriate position in order and time. So now the question is coming that what is the guarantee that it has correctly generated all the numbers of C, right? If we can show that, rest is. So first let us assume that every iteration you are generating 4 elements, right? Now these 4 elements have not been occurred in any one of them. That is the thing you have to show. You observe that in the first iteration, the difference between I and j is 0. Second iteration, see this second iteration here, difference is 1. Difference is 1, difference is 1, and difference is here not 1, it is 3. Right? Here all the elements of difference was 0. Here all the elements are having the difference either 1 or 3. Here all the elements are difference 2. What about here? 3 and 1. Now the question is coming that you have to show that whatever difference C here, that has not occurred here. Right? So this part, if difference 1 taken, difference 2 is taken care, difference 0 is taken care, you have to think or justify that whatever has occurred here, they are not here, and within the cluster they are distinct. Right? That is the only thing you have to show. And it has generated all 16 numbers. The indices of the numbers are lying between 1 to 4. Right? That is the thing. Indices of all the numbers are lying between 1 to 4. So 16 numbers, if I tell that they are lying between 1 to 4, then that must be a member of that family only. It cannot be outside the array. Right? So now everything is clear, only except these two parts. You have to show that whatever difference 3 occurred here, they are not here. Now this you can easily show that here the first index is 1, but here the difference is 3, where first index is not 1. Right? So similarly in the other case also you can show. So this is the flow of this. Now you try to write down the algorithm for n cross n matrix, right? And see that it will give me the correct output. Any questions at any stage here? So what should be the complexity of the algorithm? Huh? Or n cube? Complexity of the algorithm, time complexity. Huh? Huh?
Each rotator takes order.
Huh?
And there are order and additions in each operation.
N?
N rotators are there.
Huh?
And there are each rotator takes order.
Rotation up, why you take order in?
There are order and movements.
Each rotation you only one movement. PI will, this will move the data and this will move the data simultaneously.
Then order is.
Order n square. So, but it is not a cost of table. You have n square processor or n square time complexity. Now let us think about that hypercube, right? If you remember hypercube, and you have n cube processors. NQ processors, and you have the matrix A and B. So you observe that basically if I break the matrix multiplication theory, what it means that you need NQ multiplications, right? If I see that it is like that, Cij is equal to summation over Aik star Bkj and over k for all I and j. This is the thing, and that is NQ multiplication in the classical algorithms you need. Now, what it did in the Hypercube, the very simple idea, he has broadcasted A over N-cube matrix, over N-cube Hypercube. That is, Aik has been broadcasted to all j. That is, instead of Aik, you assume that right, this NQ processor I can write in this form, NN, right? NQ processors I can write P N N N, right? For all Ij, Aik, for all Aik, I have broadcasted that. Is it possible? Is it clear? That every j, you have Aik. Every j, you have Aik. That is Pi1k is your Aik, Pi2k is also Aik, and so on. Pink is also Aik. By some bits, how we will discuss later. Similarly, we define Bijk is your Bkj. That is P1 Jk is your Bkj, P2Jk is equals to Bkj and so on. Now you observe that Pijk for all k, they contain the element of Cij. Cij is nothing but Pi or Aijk star Bijk. This is A. Is it okay? Because Aijk contains Aik, Bijk contains Bkj, so they are multipliable. If I multiply it for different k, I can get in the process Pijk. The process Pijk multiplies the content of Aijk with Bijk and stores in Cijk. Right? So Cijk for all k, they are the element of Cij. They are the element of the Cij of the matrix multiplication. Right? Now the next step is that thisCijk, for all k you take the summation, that will be your Cij. So where is the problem? Some of your face has become little pale. Where is the problem? Tell me. Let us start again. I have a hypercube of n cube processors. These n cube processors are arranged in the form of three-dimensional array. Each dimension is of having size n. So this processor can be expressed in the form of P, N, N, N. Agreed? Now, Aij is the ijth element of A and Bij is the ijth element of the matrix B. Now what I am defining, the processor Pijk contains the three elements Aijk, Bij and Cij is the final element after multiplication. So Aij for all values of j, it contains Aik. How we will be discussing? That is implementation details. So Aik has been set for to all Aijk of Pijk for different j. Similarly, Pijk for all I, there is a Bij contains Bkj, right? Then the processor Pijk multiplies its Pijk with Bij, stores the result in Cij, then all the processors having the different k but the same ij, they are adding together and you get the Cij. That Cij is the ijth element of the multiplication. Okay? So now let us, the problem is clear. Now let us think how we can do it. Now since it is an n cube processors, so the processors can be defined as P0 to P n cube minus 1, right? Now this index Pi, you are writing in the form of Pijk. Instead of Pi, you put something else, Pl. Right? Now this index, PL you are converting into this. So this L I can always write in the form of a 3q base. Because you know that hypercube is always in the form of 2 to the power q. So this n cube can write 2 to the power 3q form, right? 2 to the power 3q form. That means this L must have 3q bits. L must have, this PL must have 3q bits, right? So first, these are the things, right? And also in the hypercube, a processor is connected. So if I put this is I part, this is J part, this is I can put K part, right? First Q bits is for I, second Q bits is for J, and third Q bits are for K. That I can do. Now, initially, what I told that initially EIK has to be stored somewhere. Initially I put EIK, this bit is 0, this bit is 0, contains 0, and initially I can put here EIK. This J is 0, right? Initially J is 0 where I have put AIK. Now after Q operations I can broadcast to all J because they are connected, right? For all J I can broadcast AIK so that AIJK contains AIK. Yes. Next part is, now you have broadcast, this part is done. This part is done. Now you are here. How to broadcast this BKJ? Now initially this is 0 and here J and here K. Initially you have put in this position, you have put your BKJ. You remember BKJ is the transpose of B, actually you are storing here, BKJ. Right? Now you broadcast it to all I. You need Q steps to broadcast. Okay? So BKJ has been broadcasted. Now perform the multiplication, which takes constant amount of time, 1 unit of time. Now you have to perform this one. This is again summation over Q, summation over Q. So you need the Q operations to collapse it. Right? In Hypercube, the question of collapsing is coming. So this summation is you need only Q operations to collapse it. Agreed? So whole thing can be done in Q steps. Right? If you have NQ process, then log n step is sufficient to give you the matrix multiplication. So cost is n cube log n. So any query on this? Here you observe that matrix multiplication has been properly, cleverly he has used it for Hypercube. If his question is if the number of processes is less than n cube, in that case you may find difficulty to achieve this. But
for scientific computations, we usually matrices are large.
oh, see, let it be clear to you. While we explain the parallel algorithms, we always assume that the number of processors is a function of the number of input parameters. Now, yes, in reality, you will be telling, sir, it is not possible. Yes, it is not possible because we cannot think that we have infinite number of processors. That n cube is a very large number for n cross n square matrix. Yes. But if you can design a new algorithm, it's good. It's good for the people to use it. There are different ways you can solve. That you assume first partitioning the matrix and partition it in such a way that your n cube satisfies that criteria. And after that again, can you combine that and other things? That is so that's why that finding the solver is a good solver is very difficult problem. And Chitra Raghavan and Anshul Gupta, they are working last 30 years only on this. See, for them, they don't want, their idea is not the cube connected. Their idea is that even if it is a shared memory one, can we have a large matrix solver? Now, once you define that matrix of different type, one maybe you can define that it is a finite matrix. Finite matrix means it is on the finite field, that is, elements are integers, modulo p minus 1, where p is a prime, or modulo p, where p is prime. But the integers or element may be very large. Not only the matrix size is large, the content element itself is maybe a 50-digit number. Right? Okay. This is one type of problem. The other type of problem is that no, it is on real domain. The number is on real field. Matrix is very large. The another one is no, matrix is a sparse matrix. Or matrix is a symmetric matrix. Symmetric positive matrix. Every one of them is a problem. But don't ask what is the size of the matrix. Size of the matrix is very, very large. That 50,000 cross 50,000 matrix you have to solve. And you know, they don't have real data whose test result is also available. Right? It's a difficult project. So whatever result you will be giving, they will be thinking, yes, this is the correct result. The next type of problem is matrix vector multiplication. Right? That is also here the problem is instead of the two matrices you will be performing A with V and you will be getting the vector V. Right? This is the, right? You remember that, right? What is that? Vi is equals to summation over A what is that? Matrix vector? U? J1. This vector is having only one. Now, can you suggest a method? Tell me. Suppose J is.
So we can group each of these Aij.
Hmm.
You can take each row. In these rows, you can connect them to like a tree. Like Aij will be connected to Ai2j and Ai2j plus 1.
Yes, yes. That is a tree model. Yes. Let us discuss this one. Very good. This is known as tree model. So here at the leaf node contains all U's. U1 in the first leaf node, U2 is the second leaf node, U3 is in the third leaf node, and so on. And you are inputting the elements of A row wise. So here you have A11, A12, A13, A14, and so on. Right? Here you have A21, A22, A23, A24, and so on. So A1 is inputted here, A12 like this. Right? At the first instant of time, first row has been inputted and multiplied. Right? Yes, resultant will be passed into the higher. While he is passing the result up, the second row will come over here. Right? And once the higher node receives the two data, he ends. And the result is sent to higher node and so on. So it propagates from the bottom to up. So after X iteration, the V1 will be out, and X is nothing but the height of the tree, which is log n. So you need, which is log m, it is m, which is log m. So after log m iterations, first result will be out. So can you tell me how much time you need to complete this matrix vector multiplication? Huh?
N minus
N log n.
N log n?
N minus 1 into log n.
N minus 1 log n?
N plus log
N plus log n?
No, sir, each row will
So
be-
you have given n log m. You have given me n minus 1 log m. You have given n plus 1 log m. Huh? And
maybe a factor of plus minus 1 in the last one.
factor of plus minus 1, n plus minus 1 plus log m.
Minus 1.
Huh?
N minus 1. N minus 1 plus log n.
N minus 1
Plus log n.
plus log m. So from here we arrive here. So see, the first row will be coming after log m, and next one onwards it is coming one by one, right? So you need n minus 1, that type of thing. So n minus 1 plus log m, right, to generate all the elements of it. So in this case you observe that this type of problem is very easy to solve on tree model. Now can you define a problem of similar type of things which can be used efficiently, the pyramid model? Just, you don't have to think now, because if it is so easy, then I could have shown earlier. So you can think to find out some problems which can be used for pyramid model, right? Can be used on pyramid model. Now, in the case of linear array, can you use, or can linear array be used to solve this problem? Can a linear array be solved? Huh? Same idea? No, different idea. So you have the linear array. have here U1, U2, U3. You have here, say, AN1, AN2, AN3, ANN, AN minus 1, 1, AN minus 1, 2. Right? So if I design this way and propagate the data this way, so first time these two are multipliable, you get the V1, V1 comes here, so at that time U2 and N2 become, V2 has been formed, so V1 moves up, V2 comes here, and at that time second part of V2 will be coming and to add it, and so on. Agreed? Yes? No? No? Yes? No? No or yes? So tell no. See, you are tilting the head, so that doesn't give me anything. Right? Either you tilt this way. See, rotating this indicates something. Then I will ask some question. But if you tell this, it is less than threshold value. If you rotate this way, I will ask you whether you are Indian, South Indian or North Indian. So based on that, I will decide. Now here it is a linear array. This is the process of P1, process of P2, P3, and so on. Right? And here it is height, so it is Pn. Now U1, while I am pumping here, AN1 also will be pumped into this, and they combine or multiply, and the data is stored here as V1. Right? Now V1 moves in the second iteration, and in the first iteration, while it is coming here, this has come here. This has come here, this data has come here, and so on. The second iteration, V1 has been moved up, and this element has come here. This element has come here. You can multiply and add with V1. At the same time, this element has been moved here, this element has been moved here, this element has been moved here, and you can multiply for and store it in V2. Third iteration, V1 has been moved here, V2 has been moved here, U3 and AN3 has been moved here to compute V3, and so on. Agreed? So finally, after X iteration, you will be generating the matrix vector multiplication result. What is the value of X? 3n 3n minus 2. This is the first answer I got. Huh? N after n iterations, you will be getting the final result. Any more? N minus 1. After n minus 1, you will be getting the final result. N plus m. N minus 1 plus m. Huh? What you have to find out what is the distance from here to here. That is the only thing you need to know, right? See, last element has to arrive here and to move it out.
N plus M minus N plus
N plus M or N plus M minus 1? This element is here. This element, how many blanks? Second row, 1 blank. Third row, 2 blanks. Nth row, N minus 1. Plus, how many elements are there? M. So it is N minus 1 plus M. Agreed or not?
Yes, sir.
Now if you think, no, I have to pump this out also, then one addition.
Coming back to this current NN in
Where are you?
the previous one, tree model,
So late?
tube light,
Yeah. Which one is?
aren't NN and equal?
Why? Need not be.
Almost
Yeah.
same order. Because
If you take the same order, then it is order n.
yes,
Then it is order n. See, it is I have taken this thing because in the vector size is not known, right? They may be different.
so I can take any tree size and
Tree size is dependent on the vector u.
then it would be louder.
Then it will be
Wouldn't it be louder?
height, log m. What if your u size is m, height will be log m.
Yes.
Yes. No ambiguity in that. I am also agreeing to that. Now if you have the number of rows is n, then it is n minus 1 plus log n. Now the first finding the solution of simultaneous linear equation. If I remember, I also need your help. You have for j is equals to 1 to n, for I is equals to 1 to n, for k is equals to, that is the thing I forgot, j plus 1 was j to n plus 1. First, let me write down the sequential algorithm, then we discuss. If I is not equal to j, then a I j is equals to a I j equals to a I k minus. Then you have for I equals to 1 to n, I equals to ai. Very, very time, because obtaining the inverse is not a easy task. So Gauss-Jordan algorithm tells what? He is diagonalizing the thing and then finding the value. Now what is n plus 1? Because I told you it is n cross n. N plus 1th column is nothing but the b has been moved to n plus 1. That is the only thing. You have A matrix and then you have B vector. Instead of putting B here, I have put the B here, which is n plus 1th column. Okay. And this is a standard formula. Nothing to. These are all. See, this algorithm can easily be implemented on parallel machine if you have n square order n square process. See, just you observe that if I right here do in parallel do in parallel. Because all these things are dependent on J only. So the J I cannot write do in parallel. Right? Agreed? Rest I can easily write. Similarly, here also I can write do in parallel. So this is an order n algorithm basically. Can you tell me why I cannot be equals to J? If I equals to J, then this becomes 0, right? So next iteration it may create problem. So basically you are doing non-pivoting element. So this is the, this can be, right? You can use it on shared memory model. Nobody tries, see, one thing you remember, numerical methods problem, generally we work on shared memory model. But people are working nowadays on cluster machines. Now, the next problem is that you have to tell me how I can do it. Root finding problem. Right. What is the answer? Y equals to fx and this, and you have to find out the root of the find out the roots of this function, right? What is root? For what value of x?
Y is 0.
Y is 0. Fine. This is known, right? For what value of x? Y is 0. Now what is the method? Let me get a method. And huh? Second method. Bijection. Which is the simplest one? Bijection is the simplest one. What is the problem in that? Demerits in bijection?
A plus B by 2.
Huh? No, what is the demerit? I did not ask what is the demerit? Of bijection.
It takes more time than.
It takes more time than?
Because it,
If the root is in any means we only go
one
half.
side, we half, so
Each
Half
iteration
root is?
not in middle means.
each iteration reduces it by half. This
No,
What is the demerit? I am
If
asking
root
you.
is-
How it giving a
If root is in one side means.
root is in one side. One side means that
one
means
side
one
means,
side.
no, one side means near the B or near A, then it takes much time because you doing half by half.
So long and time.
Yeah, log in time.
So
But
finding
log in
initial
is-
values,
Huh?
the roots, the guess, so initial guess.
Initial guess, there is no initial guess here.
So fx,
Fx automatically will know. Oh, sir, you don't know. That means the method is simple. Method is that you find out the middle one and you look for whether it is possible. That method I don't want to tell now because I want to know how much you could recollect from your school days. School means that undergraduate days.
So you actually check for the sign at the middle point. So if there are two.
Sign at the middle point, fx will not give you any sign.
Then how are you finding the root?
You tell me, I am not.
You're finding the root at the point where fx is 0.
Yes.
On either side of fx, you have a negative and a positive.
Fa is also can be left. But see, you have a graph and like this say. Now, this is negative, this is negative. Then what you are going to do? It doesn't give you anything. Fa value is negative, middle value is also negative.
The root is where it intersects with the x-axis.
Huh?
This is not intersecting with the x-axis.
But any function, if I,
We use,
okay, now you tell me.
yes.
Now your your middle one is here. Now you tell me. You are telling what? You will be finding the middle value, f of middle. Right? That is the thing you told. Then you got this middle value, which is negative. What it means?
Now the root will belong to the middle at that B point.
So initially you take
Then? Tell me what is the demerit? I am asking demerit. I am not telling that proceed.
If there are two roots and one of the halves then the sign doesn't change. So we
Yes, that bisection method fails if you have even number of rows. Right? You have. So I assume that there is no even number of rows. Right? There exists at least 1 or 3 or 5 that many numbers. What it means? It means that FA into FB, FA into FB must be negative. Or FA and FB, they have the two different signs. That is the assumption we are making. That means that exists, that means that it has odd number of rows, right? Don't make the complex, real root complex root. I never told that real root. Right. See now, the scenario is that you have FA dot FB is less than 0, that assumption you are taking. Now, procedure is that you take the middle value, and then you multiply this with this one. If you find they are having this greater than 0, then the root is lying this side. So you will be starting from M and B, this becomes your A, and again you divide and so on. Till you get the root, or the distance between these two is very small. Right? Range is very small. Because after that you find that it is not convergent. Now, this algorithm can easily be implemented on parallel machine, even though you feel that it is a sequential in nature. The simple thing is that you have A and B, and you have suppose n processors, so you divide into n groups. Right? And you assign one group to one processor, and he finds that in which zone it lies. Suppose you find that this is the zone where you get the FA and FB, after multiplication you get the negative sign, then this is the zone. Now you divide this zone again n groups and you proceed. Right? So root finding, even though you feel that it is a very complex, very sequential in nature, but writing a parallel algorithm for root finding is not a problem. Now think about the Newton-Raphson method. Newton-Raphson method, I forgot the formula. Who can help me in writing the formula? Xn is equals to bus? और कुछ था ना?
this one is correct.
Correct?
That's it.
Good. And you need something x0. That is the thing, he has the sheet value here. And Newton-Raphson method is selecting the sheet value is important. Suppose you have very good sheet value and other things. Here also a function is always defined between A and B, right? So instead of selecting the sheet value, what you do, you divide this into n groups, right? x1, x2, xn, right? So B minus 1, B and A are dividing into n groups, right? Here it is your A is x0 and B is your right? So you use this as sheet value. Use this as sheet value. Process Pi, use Pi xi minus 1 as the sheet value. And then you obtain the distance between. See, you have to obtain this distance. You have to obtain this distance, right? Even if it is less than epsilon, then only it will be, right? But you remember, as in the case of sequential algorithms, this algorithm also does not give you the quick or guarantee of convergence.
We
Right.
just have n different processors trying to converge at the same point.
No, it will not. It will not, because his zone is this. Every processor, I will not allow him to access the other zone. Right? Then the conflict and other things will be coming into the picture. His zone will be up to this. His zone will be up to this. So this is about your numerical methods. I don't know, there is several parallel numerical method books available.